building. I'm going to go set the arm to approximate initial condition of the sine wave that we wanted to track, and that was about 1/2 meter in front of the base tracking point. So by setting this up here, we can now reach the approximate starting point of the sine wave. So it doesn't, like, we could start the arm way over here, but then when we turned it on, it would oscillate wildly to try to come back to that initial point, and it would have a giant transient. So basically what I'm going to do is I'm just going to start it approximately at the starting point so we don't get that huge transient. Okay, so now the robot's all set up, and I guess you can just videotape that, CP. And so now all I'm going to do is connect to the target, because it's done building. All I have to do is hit the connect to target button, and then just hit play button in Simulink, and we should be all set. And so now the robot's just going through, and the base is tracking a straight line, and the end effector is going to be tracking the sinusoid. Okay, I'm going to hit the stop button in Simulink, and that just automatically stops the robot. Because if no signal is being sent to the motor controller, then the motor controller defaults to 0 output, and so then the robot just naturally stops. And now I also have a graph routine in here to graph that data. I'm going to open that up. It's called plotrobot.m. It's just an M file. And so the only thing I have to change in here is the num seconds variable, and however long I ran it for 54 seconds, so I'm just going to change num seconds to 54, and then I can just hit F5 to run the M code, and then you'll see the robot just plot the trajectory that I just had. It's actually pretty good. So you can see the end effector tracking the sine wave and the base tracking a straight line. Okay, and now as we move the robot back, I just want to make a few notes. As we move the robot, try not to exceed high velocities on either the end effector by moving the end effector too fast or by moving the robot too fast, because you can easily damage the gearboxes, you know, if I all of a sudden just move the end effector really fast. And so we just want to be reasonably gentle with it while back driving the motors. And what else? I think that's it for now. Yeah, you can stop it. The batteries for this robot consist of a 12-volt, 12-amp-hour battery for the PC104, and then for the motors we have two 12-volt, 6-amp-hour batteries connected in series in order to make 24 volts. If you want to replace the batteries, you can just slide the battery right here out the side, and in order to do that, I just tried to do it a minute ago, and the wire, that's as far as it comes out, as far as until the wires get tensioned. So like you can simply pull the motor controller off and then feed that wire right there. That wire actually feeds down in and connects directly to that battery. And so you can do that, and then the battery can actually be taken out to be changed if necessary. But I just keep the battery in there for purposes just so we can charge it while it's in the robot, because it's kind of a hassle. But if it needs to be changed, that's what can be done. So in order to charge the battery, basically all we have to do is take the charger and just connect the terminals, red and black, and you'll see that the charger went from green to red. And if it's connected and it's green, then it's fully charged. If it's connected and it's red, then it means it's charging. And so this charger is a 2 amp charger. And to fully charge a 12 amp hour battery, it would take about 6 hours. You'll know when the batteries are fully charged because they'll be around 13.5 volts or so. And if the battery, you'll have to check the battery voltage. If it gets below 12 volts, then it's time to recharge. And for lead acid batteries, you never want to run it lower than 12 volts. Unloaded, that is. You know, if you have the PC104 on and it's running, then you might get 11 volts, you might get 10 volts or somewhere in there. But when it's unloaded, that means everything's turned off and there's no current being drawn from the battery. That's when you check the battery. And if it's lower than about 12 volts, then you must recharge it. And if you run the battery dead on a lead acid battery, then it's dead forever. So don't do that. Can you come around this SCP? And so now when it's time to charge the motor batteries, there's 2 of them, of course. So you can just pull it out about this far and then just connect the charger here for this one battery and then connect the charger here for this other battery individually. And then that's basically all you need to do to charge the motor batteries. And one other note, if we eventually get 2 chargers, there's a wire here, this wire here, connects these 2 batteries into series. And so in order to avoid ground problems, you must disconnect this when charging if you're going to charge both these batteries simultaneously with 2 separate chargers. Otherwise, one of the chargers' ground will be 12 volts above the other, and that is not a good thing. So I guess once more, if you're charging both the batteries with 2 chargers simultaneously, you must disconnect them from series. But otherwise, if you're just charging one at a time, then it's fine to leave them connected. And then these also must be checked and maintained to always be above 12 volts in the unloaded condition. Okay, when resetting the encoders, we have to push a button on the encoder card, which is the bottom card here. And the button is right behind the blinking green light. And so basically I'm just going to use a non-conductive item such as a pencil because I can't reach my finger in there. So the button's right back here, and when I push the button, you'll notice I'm going to push the button right now. See, the green light flashes very rapidly, indicating that the encoders are actually reset.